Welcome. Glad you can make it on this first day of winter here. So the material that we're going to cover on this PowerPoint, and if you're not sure, it's the PowerPoint that was originally for Friday. Now we got some of the way in. This will be the last PowerPoint that's going to be on the test. Remember, the test is on Friday. For the test, I will put up the equation sheet. Probably like by Wednesday. The periodic table is already up there, so make sure you download that. Make sure you have a calculator. You can have blank pieces of paper. The test will be under course content on Blackboard. And the way it's going to work is that the test will open at 12 a.m. on Friday and close at 11:59 p.m. on Friday. So you have any time on Friday to take it. And once you start it, you have 16 minutes to finish it. So once you open it, the timer will start. As mentioned on the announcements, we will be using ProctorU to have some accountability for the test. So make sure you do the extra credit opportunity I put up. Check your system to see if it works with ProctorU. Put up your screenshot of everything showing that it's green and it's good to go. And if there are any problems, make sure you contact ProctorU or contact me, and hopefully we can work that out for you. But with that, let's get to the actual material, the last material that's going to be on test one, and that is how to balance chemical equations. So first off, let's just talk about chemical equations in the general sense. A chemical equation is going to tell us a process. And the process is we have some reactants going to products. So the left-hand side of the equation is called a reactant. The right-hand side is going to products. And the arrow is just telling you which way the reaction is going. The A, B, C, and D here, these are just general representation of molecules. So these would be molecules or elements. But a lot of the times, if I just want to show you how an equation works, I'll use A, B, C, and D. The important thing about chemistry, though, is that we aren't destroying any atoms. So any atom that goes into a reaction as a reactant must come out as a product. So what goes in must come out. In the process of making sure that the number of atoms are same on the reactants and on the products, this is called balancing. And so to begin with, we're going to see how we balance equations. So I will do A for us, and then I'll let people have some practice doing the other equations. So here's how you balance equations. So the first thing I like to do is I like to write down every single element that's in my equation. So for A, I have 3 elements. I have carbon, I have hydrogen, and I have oxygen. So what I do is I write down the elements just in a column like that. Then what I do is I'll make like a T. And the left side of the T is my reactants. The right side of my T is my products. So the first thing I'm going to do once I have that little chart is just count how many atoms I have on each side of the equation. So for carbon, I have C5 on my reactant, so I have 5 carbon, and my products only have 1 C, so that's 1. Hydrogen, I have 12 on my reactants, 2 on my products. Oxygen, I have 2 oxygen as a reactant and 3 oxygen as a product. So 1, 2, 3 as products. Now, let's try and balance this reaction. So I need to have the numbers be the same. That is, the number of carbon in the reactants has to be the same as the products. Hydrogen has to be the same reactants products. Oxygen has to be the same reactants and products. Generally, when I balance stuff, if an element's by itself, and what I mean by that, like O2 is by itself, I will try to balance oxygen last. So anything that is bonded to itself, usually I touch last. So that means I can balance carbon or hydrogen first. And when given a choice, I usually like to always try and balance carbon first. No, I guess I can't think of a good reason for that off the top of my head. You could go either way, hydrogen or carbon. So I'm going to try to balance carbon. Right, so the way this works is that we put a number in front of an element. And when we do that, instead of 1 carbon, we now have 5 carbon as a product. And the math that I'm doing is that if there's no number next to an atom, that number is actually 1. So what you do is you do 5 times 1. So now I have 5 carbons as a product, but this 5 that I put, you also have to do that for oxygen. So I'm saying I have 5 molecules of carbon dioxide. So now I have to count the total number of oxygen I have on my products. So I have 5 times 2, which is 10, plus 1 more, which is 11. I now have 11 oxygens as a product. So carbon is balanced. I'm good with carbon. Next is hydrogen. I have 12 hydrogen on the left, 2 on the right. So I need to have 12 on the right. Well, 6 times 2 is 12. That makes 12 hydrogen. Now to count my oxygen. So I have 5 times 2, which is 10, plus 6 times 1, which is 6. So 10 plus 6 equals 16. All right, my hydrogen is balanced. The only thing that I have yet to balance is my oxygen. So I have 16 on the right-hand side, 2 on the left-hand side. So 8 times 2 is 16. Now I have 16 oxygens. And there's my balance equation. C5H12 plus 8O2 goes to 5 carbon dioxide plus 6 waters. This is the chemical equation for burning pentane. So now that you've seen A, is there any questions about anything I did there? All right, try to do B, and let's see here. All right, so I actually have like a new way to gauge our progress. So try to do B, and I just put a poll up. Let me know if you're finished with B and you feel confident, finish and not sure. You got part of the way and not sure, or you have no idea how to begin. Just a way so I can gauge where people are at during our live session. Otherwise, if you have questions, let me know. But I'll let people get to it. Oh, and if the poll's in your way, you can always minimize it and reopen it by going to the poll button at the top. I see that few of you are done with B. Most of you are done with B. So feel free to go on to C. Once you do that, all right, so it seems like most of us are finished and you got an answer there, but not sure. Okay, so let's do B really quick. B is probably a little bit easier than A. So zinc, HCl are 3 types of atoms. Then we have reactant, product. So 1 zinc on the left, 1 zinc on the right. 1 hydrogen on the left, 2 hydrogens on the right. 1 chlorine on the left, 2 chlorines on the right. So zinc is good to go. Don't touch that. Hydrogen, chlorine, though. 2 on the right, 1 on the left. That's an easy fix. Just put a 2 right there. And now it's 2H, 2Cl, and we're all good to go. Right? So I'm going to reset this poll, but let's try it for C now. Try and get through C. And I'll just put up the beginning stuff for C. Yeah. All right, so that should be our starting amounts for C. So question, would you put parentheses around the HCl in the reactant? No, parenthesis is usually only done for something like calcium hydroxide, where it's the parenthesis is saying that this ionic compound, the anion is polyatomic. So it's saying like that OH is in a covalent bond, while the whole compound's an ionic bond. So that's generally what you use the parentheses for. Yeah, on B, you wouldn't put a parenthesis because you don't have any covalent bond in that compound. Like you're asking, do we do this? And you don't. The parenthesis is, that's why I was explaining within C, because that's where we have the parenthesis. That parenthesis is saying that OH is in a covalent bond, even though the whole compound is ionic. And that two is saying I'm only working on the OH, while the 2 out here in HCl is working on the whole compound. So you never like add parentheses after the fact. The parentheses are there for our polyatomic ionic compounds. So that is, yeah. Generally, you don't put parentheses around the whole compound because it's not telling you any information by doing that. Okay, so it seems like for C, we are getting some progress, but not quite sure how to finish it. Some people are finished. So let's start doing this then, since we do have a fair number of people not quite sure how to continue. So let me get my eraser out. All right, so where to start with this? So this one's a little more complicated. When you have long equations like this, generally where I start is I start with elements that only appear once on each side of the equation. So that would be either calcium or phosphorus. They only appear once on each side of the equation, while hydrogen and oxygen appear multiple times. So let's try and balance the calcium. So 3 calcium on the right, 1 calcium on the left. So I'm going to put a 3 in front of there to make that 3 calcium. Now let's do our math. So I have, so this is really, we can distribute, right? So that is really 3 times 2 oxygen. So that compound on the left has 6 oxygen plus 4 oxygen is a total of 10 oxygen on the left now by putting that 3 there. And we have 3 times 2 hydrogen, which is 6 hydrogen, plus 3 hydrogen. So 6 plus 3 is 9. Now, since we have our calcium balance, I'm going to do my best not to try and mess with calcium. We can go on to phosphorus. 2 on the right, 1 on the left. So let's put a 2 there. So our phosphorus goes to 2. Now to count our hydrogens. So I have 2 times 3, which is 6, plus another 2 times 3, which is 6. So that is 12 hydrogen on the left. Now 2 times 4 oxygen, which is 8, plus 3 times 2, which is 6. 8 plus 6 is 14. So now our phosphorus are balanced. The only thing left is our oxygen and hydrogen. So if I just focus on hydrogen, I have 12 on the left, 2 on the right. And remember, our calcium and our phosphorus is already balanced. So I'm going to try not to mess with this compound. I'm going to try and leave this compound as is and just mess with water. So 12 hydrogens on the left, 2 on the right. You put a 6 in front of there. 6 times 2 is 12. Oops, that's a pretty not good 12. 12. 6 times 1 is 6, plus 2 times 4 is 8. 8 plus 6 is 14. That is a balanced equation. All right, last one. Let's do D. So I'll put the poll back up there for D. And if you have questions how I did any of that, feel free to ask. And I'm going to put up our starting conditions for D. So Al, C, O, H, and P. We have 5 elements in D, getting even more complicated. Reactants, products. 2, 1. 3, 1, 13, 7, 7, 13, and 8, 9. Oh, I'm looking at the wrong one. Whoops. That is 7. 3 hydrogens and 2 hydrogens. 1 phosphorus and 1 phosphorus. Actually, I know you're still working on D. I'm gonna end the poll and just go ahead because D's a little tricky. And for time, I'm gonna walk you through D. The reason why D is tricky is that phosphorus is balanced, but you're gonna see we're gonna mess with this and make it unbalanced because that's the only way to solve this. So let me erase all this stuff so I have a little bit of room to work. All right. So again, general rule of thumb, when balancing, pick the element that only appears once on each side of the equation. That would be Al or C. I'm going to pick aluminum. You could also do this with carbon. So 2 aluminum on the left, 1 aluminum on the right. So I put a 2 there. That goes to 2 aluminum, so aluminum's balanced. Now I have 2 phosphorus, so I just unbalanced my phosphorus, but you have to do that. A common mistake I see with balancing equations is that students will try to use like fractions. So you might be tempted to put a 1/2 on aluminum 2. You can't use fractions. You can only use whole numbers. So the only way to balance aluminum is to make phosphorus unbalanced. And now to count my oxygens, 2 times 4 is 8. 2 times 4 is 8. Plus 2 is 10. Plus 1 is 11. Right. So aluminum is balanced. Let's do carbon now because it is only appears once as well. So 3 carbon on the left. Now I have 3 carbon on the right by putting a 3 there. My carbon is balanced, but I messed with the oxygen, so let's recount that. 2 times 4 is 8. 3 times 2 is 6. 8 plus 6 is 14. Plus 1 is 15. Right. So we have aluminum and carbon balanced. My next element that only appears once is phosphorus. So let's balance that. 2 phosphorus on the right, 1 on the left, easy to fix. Put a 2 right there. Now phosphorus is rebalanced. Now to recount my hydrogens and oxygens on the left. 2 times 3 is 6, so 6 hydrogens. 2 times 4 is 8. 3 times 3 is 9. 8 plus 9 equals 17. So aluminum, carbon, phosphorus balance. The only thing I have left to balance is hydrogen and oxygen. And hydrogen, we have 6 on the left, 2 on the right, and only one place where I can balance. So I'm going to put a 3 here to make that 6 on the right as well. Recount our oxygens. 2 times 4 is 8. 3 times 2 is 6. 8 plus 6 is 14. 3 times 1 is 3. 14 plus 3 is 17. That is a balanced reaction. And for test 1, D is probably as complex as we are going to see. All right. Now that you've had practice with balancing and seen balancing, any questions about balancing equations? Okay, we can move on then. The last thing that's going to be on test 1 is carbon compounds, how to name carbon compounds. And those of you taking organic or will take organic chemistry, you'll look at a lot of this, but I just want to get the basics down to begin with. So what we're going to focus on for test 1 is basically this section. So out of all the stuff that's on this slide, just circle this section and also this row. I will explain everything so we know what we're talking about, but only the highlighted stuff is going to be on test 1. So naming carbon compounds. If a compound contains carbon and hydrogen, that is called an organic compound. Well, really any compound that has a lot of carbon in it is generally organic. But we name carbon-only compounds according to some rules. One of those rules is that we call them based on how many carbons we have. And you see the word hydrocarbon here. A hydrocarbon is simply carbon and hydrogen. That's what hydrocarbon stands for. In the number of carbons, you give it a prefix. So 1 is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, so on and so forth. So if you ever wonder what octane meant, that just meant a compound with 8 carbons and hydrogens. But don't worry about memorizing this. I won't ask you this on test 1. If you take organic, you will have to know this, but for test 1, we don't need to worry about this. What we do need to worry about is the number of bonds in a carbon compound. We give it a special name. So if a hydrocarbon compound, that is a compound with carbon and hydrogens, if it only has single bonds denoted by these lines of just 1, it ends in ane, A-N-E. So this compound, the formal name would be propane, because prop means 3 carbons, ane means single bonds. Those of you who watched King of the Hill back in the day, this is what Hank Hill was selling, propane and propane accessories. If a carbon compound has a double bond, which is denoted by these 2 bonds, and you only need 1 double bond to qualify. If you have a double bond in your formula, you end in ene. So this compound is ethene, because F means 2 carbons, ene means a double bond. So ethene, 2 carbon compound with a double bond. If you have a triple bond, which is these 3 lines, you end in ine. And again, 2 carbons, so ethyne. So the recap: single bonds A, double bonds E, triple bonds Y. And it's nice they all follow the alphabet, right? A is the lowest, so you have the least amount. And you only have single bonds. Now, if your carbon compound has an OH group, the way you change it is instead of this E here, you change that to OL. So a compound that only has single bonds and 2 carbons would be F and all. F coming from the number of hydrocarbons, so 2, and coming from only single bonds, all coming for this OH. Ethanol is the thing that gets you drunk, while methanol, so what I just drew there is methanol. So meth, 1 carbon, and only single bonds, all OH. And the only difference between methanol and ethanol is 1 carbon. Methanol will make you go blind if you drink it. So just 1 carbon is the difference between being drunk and being blind. But that is our naming scheme for carbon compounds. Any questions about that or what I want you to know for test 1? For balance and equations, it doesn't really matter we do something on both sides as long as we balance them out or not. As long as each side of the equation is balanced in the end, it really doesn't matter. You can do anything you want to the side of the equation as long as it's not a fraction. So will we be giving the prefix listing for naming carbon compounds? No, I won't give you that list because I won't have any questions relating to that. I'll show you the type of questions I'll have in a minute. But basically, it's just the question might be like I give you ethane, and I just ask you, is this compound ethane, ethene, or ethine? So I would have like a multiple choice or ethanol and just have all the names there listed for you. But they would have the correct prefix because I'm not testing you on that. I just want you to be able to look at a compound and know if it's an ane, an eine, or ane, een, or ein, or an all. Yeah, just the ending. That's what I'll be testing you on. Now, what we've been looking at and what really organic chemistry is what are called organic compounds. And generally, an organic compound is a compound if it contains carbon. There are exceptions. CN, which is cyanide, is not an organic compound. Carbon monoxide is not organic. Carbon dioxide is not organic. And there's more. But if it contains carbon and hydrogens, usually you call it organic because usually it comes from organisms. Those of you who like organic foods, or if you ever wondered, what does the label organic mean? Usually what that means is that the pesticides they use are organic. And I'm just showing you 4 examples of organic pesticides here. If you look at their structures, I know you're not used to looking at complex chemical structures. Basically, anytime you see lines like that, the point on those lines just mean there's a carbon and hydrogen there. But yeah, organic food just means that like the pesticides that were used are organic. That is, they're only made out of carbon, oxygen, and hydrogen, sometimes nitrogen. But yeah, that's what an organic compound is. And organic chemistry is the study of basically carbon. So a question is, I want you to look at these 4 compounds and try to deduce if we're looking at a organic compound or an inorganic compound. So basically tell me if this compound's organic or not. I have a poll for that. So based on what I just said, are these compounds organic or inorganic? All right, so it looks like the majority of people are in, so let's go over this. A is actually, even though it has carbon, A is inorganic. Okay, so let's figure out the rules. Because let me just go over the other ones, and I'll go back to A. So B, carbon, hydrogen, organic. C, carbon, hydrogen, oxygen, organic. D, LF, inorganic, no carbon. If it has no carbon, it is automatically inorganic. So let's talk about the special case of A. So usually, if it only contains carbon and oxygen, it's inorganic. Usually you need a hydrogen there. Also, when you have a metal in it, a lot of the times, not always, but a lot of the times that's going to make it inorganic as well. So to be organic, what you're generally looking for is you generally want carbon and at least one hydrogen. Then you can have the oxygen in there. But rough rule of thumb, if it's only carbon and oxygen, generally inorganic. Otherwise, if it has carbon, organic. Or if it has no carbon, that's an easy one. That's inorganic. But these are just very basic rules that I'm introducing you to. And like I said, if you go on to organic chemistry, you're going to get your head pounded over and over again with this idea. But just so when you go in there, it's not 100% new to you, only like 95% new. So any questions about that idea? So when carbon is next to an oxygen, it's inorganic. No, not there. You can definitely have, so this, that is organic. It's usually if it's only like carbon and oxygen. So like this, there's like no hydrogen there and only a metal. So that's what makes it inorganic. So metal plus CO, that would be inorganic. If it's just like C and O, or how many numbers of O's you have, inorganic. There are exceptions to that. Carboxylic acid is actually organic itself. So this is organic. I would never ask you that though, because that's too mean. Too mean of a question, because it goes against the rules, and that's just something you learn. But the rule of thumb is, for right now, if we're just looking at carbon and oxygen, we're going to say that's inorganic. Yeah, so C, right, is carbon, oxygen, carbon, hydrogen, and oxygen. So that makes it organic. Right, any other questions? All right. And here's like a question I was saying that I might ask you on test 1 to deal with our carbons. Please tell me if we're looking at an alkane, alkene, or alkyne for A, B, and C. Then D, I want you to change that into an alcohol for me. And I'll give people like a minute for this, and then I'll go to the answers. I forgot to make a poll for this one. So I'll just give people like a minute to answer. All right, so for A, double bond, that's an alkene. And I didn't mention this, but the prefix alk just means carbon and hydrogen. That's the generic prefix for carbon and hydrogen compounds. So that would be an alkene because it has a double bond. B, only single bond, so that's an alkane. C, that's a triple bond in there, so that's an alkyne. And D, if I want to make an alcohol group, I can add an OH like that. One thing to note, carbon can only have 4 bonds. Carbon can only have 4 lines drawn to it. And when we put like a CH3 like that, that is just shorthand for saying there's 3 hydrogens bonded. So if I want to add an OH group, which looks like this, I need to remove one of the hydrogens, or else carbon would have 5 bonds, and carbon can only have 4 bonds. So keep that in mind. You will never see that violated. But yeah, that's all I expect of people for our organic compound section for test 1. Can you like determine if we're looking at something that's organic or inorganic? And can you tell me if we're looking at alkyne, alkene, alkyne, or an alcohol, which ends in all? So any questions about what I expect of people? All right. So it's 10:45, and instead of going on to our next PowerPoint, I think I'll just save that for Wednesday, which is okay because I didn't have any extra stuff planned for Wednesday. So Wednesday will be our chance to catch up. At this point, is there any questions people might have about the test or anything at all in the last couple of minutes they want to ask? What sections is the test covering? So I actually don't know the sections off the top of my head because it's been a while since I made these PowerPoints. You will find everything in the test 1 folder. So if you go to Blackboard in class test 1, we'll have everything. And it will be up to the Friday the 12th folder on our course content, which, let me go look at the reading guide because that should have it. Reading guide 9. Yeah, I don't know the sections off the top of my head, but it's basically up to this PowerPoint and everything before it. All the practice quizzes are like how you would ask the questions. So basically the questions we do in class is how I'm going to ask the questions. So it's going to be few multiple choice, more short answer in that I'm asking you to do calculations for me. Your best way to study 100% is to go through the problems we did in class. Make sure you know how to do those. Go back through the old tests. Make sure you know how to do those. Go through the practice problems the extra practice problems I put up. Make sure you know how to do those. It's very much question based. Well, if you do have other questions, want to know anything, always feel free to email me. As long as I have power today, I'll reply when I can. If you want to set up extra meetings with me during the week, feel free to do that as well. Just shoot me an email. I'll be happy to walk you through any problems you're still having. Otherwise, study hard, stay warm, and hopefully I will see people on Wednesday. Right. Take care, everybody.